start this problem by reading it through, then working it on your own. So pause the video and work it on your own, and then play the video so that you can watch and check and make sure you got everything right and hear any other little additional details I give about the process, and then we'll do a second half of the problem here after we go through that. All right, now what tells us how to approach this is the fact that the value is changing by a given percent every single year. Because of that, we can know that we're going to be using the compounding interest equation. And so in using this equation then, about the only thing that will tend to throw people off usually is this right here, the rate. Because a lot of us really want to say it's going to be 1 plus 0.25, because 0.25% is a decimal. Well, not quite. It's a percent. It just happens to be a percent that includes a decimal. And so it's not actually going to be 0.25 there. I still am going to have to take that 0.25 and divide it by 100 if I'm going to turn that just into a decimal that I can actually multiply by. And so that is actually going to give me 0.0025. That's the number I need to use in my equation. Right. Once I have that part in there, then it should just be a matter of doing the calculations. So I do the part inside of the parentheses first, then I do the exponent, then I do the multiplication, and we end up getting $510.09. A modest increase, typical of a savings account. But I want to follow this up with another question. What if this account decreased in value by 0.25% each year? Perhaps they're applying some fee to an account or something like that. How would this equation change in this case? Well, instead of adding our rate, we're actually going to have to subtract it, because it means that instead of going up by that amount, we have to go down by it. In other words, it's like a negative rate that we're plugging in there. Now, once we see that that's supposed to be subtraction instead, then we go ahead and do the math like we normally would, following order of operations. And we end up with $490.09. Now, I want you to note something about these two answers. First of all, they both end in 9 cents. That's total coincidence. That's not anything mathematical or special about it. That's just coincidence in this case. But something else I want you to notice here. This one, our first one, increased by $10.09. In our second example, where we're decreasing by that amount, it decreased by $9.91. Notice that when we are increasing and decreasing by percentages like this repeatedly over time, the amounts may not always be quite as intuitive as you might think, because a lot of people think, oh, well, it'll be the same amount that it goes up as it goes down. But it's not. And so we really have to know these equations and use them for a while before we can really build up some of those instincts.